Eating now at a restaurant, I'm including all kinds. McDonald's, Arby's. You're just not cooking at them. The town restaurant, all of those. So we have this data set where X is related to Y. X is the number of times you eat, maybe lunch, dinner, breakfast, outside of your home, and Y is the amount of money that you spend per week on food. We have the data. The very first step that one does is to determine if, in fact, there is a linear correlation between X and Y. And to do that, we use a scatter plot. Let's see. So I want to enter the data X and Y. So X is the number of times that you eat. That's that. So press start. Obviously, start distance. Number 1. And you get a table just like Excel, etc. I'm going to enter X values in list 1. So 1, 2, 3, 4, 5. By default, the calculator will assume that list 1 contains X values. And list 2 will contain Y values. I believe Excel does the same thing if you don't specify. So I'm going to enter the amount 55, 62, 71, 84, and 99. Right. Good. Now we need a bunch of descriptive statistics. Before we get to that, let's plot this and see if there is a linear relationship. As the number of times increases, the amount increases, perhaps things are linear. So press second start plot for Y equals and turn on the plot, so select 1. over to on. Got a bunch of options. The very first one is a starting point. So leave it as is. As I mentioned earlier, called the X list would be list 1, Y list would be list 2. And let's go ahead and graph. You see nothing because the scale is off. To get to the start plot or the scatter plot directly, all you have to do is press zoom. No. Yes, how about that? Pretty linear, right? Yeah, zoom 9. Zoom 9. If you scroll through the zoom options, I believe that's stop. So zoom stop. So zoom 9 seems pretty linear to me. Do you agree? Yes. So a linear model is appropriate in practice. If you don't see a linear plot, I've seen this happen multiple times. People come to a presentation. The data looks all kinds of messed up. It's not linear, and their entire presentation is based on a linear model. Yes. So don't do that. It doesn't have to be perfect, but it has to show a pattern that's linear. Now that we've assessed that part, we want to get some statistics here, descriptive ones. We need the means in our formula. We need the standard deviation. So, which is why I did the derivation. So here we go. Press start. Over to calc. Number 1. First, I'm going to start with list 1, which is 4x. Second, 1. Second, the blue button followed by 1. Enter. The meaning x bar is 3. We can ignore the sum of x, we don't need it. Sum of squared x values, don't need it. What we need is Sx. So Sx is simply Sx that I have here. So x bar is 3. Sx, we can round it to 2 decimal places, 1.58. I want you to try for y bar. Let's see if we can get it. Oh, for y. What are the values for y bar and sy?
Sorry, 4.2.
7.74.2.
17.598. So how many?
Good. So the process is very straightforward. Press start. Over to calc. Number 1. Instead of L1, we have to call L2 because y values are in L2. So second to enter. And mean is 74.2. Standard deviation is 17.598. Going to round it and put it as 0.60. On an exam, I'll tell you how many decimal places you have to round to. So we want to find beta 1 hat. And the strangest thing with the calculator is you can't get the value of R directly. You have to use the linear regression procedure to get it. But then when you do the linear regression procedure, you'll know the answer right away. Yes. I won't make it as easy on an example. I will show you how to do this. But before you get to the blend rate card, pick up your calculator, click on mode. I'm quite sure mine is not going to go past 4 second. For some reason, I've tried all kinds of things and it won't work. But if you keep on pressing in your calculator, it should scroll down and you would see an option that says Start Diagnostics. See it? Yes.
If you could second 0 for work.
I know.
Okay.
I just didn't want to do it, but I'll explain.
Gotcha.
So this is the easier option. So if you scroll down, you should see Start Diagnostics. Switch it from off to on. Hit the forward start. Now, if your calculator is like mine, you can't do it. We're going to avoid anything. Press second, 0, and you can sit there and scroll, or you can press the X inverse button to take you to page D. So, in other words, words that or functions that start with the letter D. Scroll down gently and diagnostic on, enter, you're done. Yes, but most of you have the newer version, so just use the mode option. Once you turn it on, it will remain on until the end or until you reset your calculator. So don't want leave it as is. Now go over to Start Calc. Option number 4. Blend rate. I wonder what that would stand for. What does it stand for? Linear regression. Now you don't have to specify anything. When you enter, the calculator is going to assume list 1 is X and list 2 is Y. But if you want to be particular, second 1, comma, second 2, that suggests that list 1 has X values, list 2 has Y values. So, our rotated model Y hat, according to the calculator, is 11 beta naught hat plus 41, power backwards, 41 point, no, 11 beta 1 hat times X, that's the slope, plus the intercept, 41.2. But to show you one more thing, if you look at the output, we have the value of R, which is 0.9883. We need that for this part. We should expect a very high correlation coefficient, close to 1, because our line, our scatter plot indicates the data is pretty linear. So this is what I want you to do. We know the value of R. Of course, we know the fitted model already, but I want you to try these 2 formulas and see if you're able to get the same model, which is 11x plus 41.2. We know x bar, we know y bar, we know the standard deviation of x, we know the standard deviation of y. Put it all in and see what you get. So we have the value of R, which is 0.9883, and multiply that by standard deviation of Y, 17.6, divide by 1.58, and what do we get? 11.00 something.
Yep, 0.089.
Okay, 0.009, rounded to 2 decimal places, that would be the same as 11. We take the value of mean, 74.2, minus 11 times the value of x bar 3. That is 74.2 minus 33, 41.2. Matches that. We do have to be a bit cautious. If you're using the calculator and putting in values directly with 9 decimal places, things might be different. Your values might be slightly off. Instead of 41.1, you x equal 2, you may have 41.1. Don't freak out. Rounding will affect the constant, which is why I will specify on the exam as to how many places you must use. Or should. Are we clear? So we have the fitted model that will give us the fitted values. So we started with a theoretical model. We have the data, we visualize the data, and now we have the fitted model. This model will explain the relationship between the amount of money that you spend on food per week and the number of times that you eat at a restaurant per week. Now, later on, we will talk about prediction. This particular example, when you predict, you are going to get, say, for instance, 2.2. Yes, but you have to think about it rationally and say, well, can you eat 2.2 times at a restaurant? No, you can't. You have to round to the nearest integer. This is a short example. The book goes over in detail on how to use the summation formula and do an example, but as I mentioned, use your calculator. Sounds good?